All right. First, thank you. It's Friday. It's afternoon. It's sunny outside, and thank you guys for being here to see us talking about a little bit on single-page applications. Is your design secure? So I'm Rafael. This is Murali. We are security engineers with Microsoft. More specifically, we're part of the Serpent. Is one of the red teams with Microsoft. Our team provides services for Xbox and Windows as well. And that's a little bit of ourselves. So we'll talk a little bit today on why SPAs, why they're popular right now. Right? They are lighter, faster, easier to port to mobile. You have tons of new frameworks out there, Angular, React, most popular ones, you name it, that make easier for you to transition from this old way to do web applications with MVC, Spring, all those kind of ancient 90s, early 2000s frameworks. In this presentation, we're going to describe a little bit of the security pitfalls that affect you on the process of migrating from this traditional web application development to single-page applications. A little bit on background, old model, right? It used to be, you have a browser, of course, a web application. Browser makes a request, server will process, returns you an HTML. Simple. The caveat here is every time that you have to refresh the web page, browser will make another request. Server will process it, send you full back of HTML to your browser. This new paradigm, single-page applications, beautiful. You still have a browser, make a request. Server will process, will get back static HTML, some JSON, some JavaScript. The caveat here is every time that the browser needs to update the UI, it will make a callback to the server sending JSON data. And the refresh on the UI will happen locally without the need of having the server to process another request or render or generate HTML back to you. And this kind of, we have a transition, right, on this stateful versus stateless applications, right? On the old days, you have section variables, view state, cookies, for you to keep track of your request. Each request depends on each other. The previous request depends on the next request, and so on. With single-page applications, they are different. Each request will happen in isolation. That means that the next request will not depend on the previous, and so on. What that means, that you have to verify for authorization and authentication every time that you send a request to the server. This simplifies stuff, but we need to make sure that we don't assume anything.
So going into authentication, in a traditional web app, what you see here is a diagram describing authentication with an identity provider. So the first time the user logs in or tries to access a web application, they get redirected by the web application to the identity provider. The user logs in, gets back a token. The browser sends the token back to the server. That creates a session on the server side and sends back a cookie to the browser. And any subsequent request from the browser will send that cookie along and identify itself. In a single-page application, the implementation on the server side is much simpler. So the only thing that the server has to do is check whether a valid token is coming along with the request. So it is up to the browser or the JavaScript that's running on the browser to make sure that it attaches a token with every request. So in this case, the browser would automatically go to the identity provider if it doesn't have a valid token and get a token by logging the user in. Once the user is logged in, it makes requests to the server using JSON preferably and sends the token along with every request. So what we see a lot is JWT tokens being used, and that's kind of the standard for single-page applications right now. What all this means is that we are going to make the cookie monster really sad because we are going to say that we shouldn't use cookies anymore, and any SPA should really use the token-based approach for authentication. But this also means that things that you take for granted with cookies are no longer there. So things like same-site cookies or HTTP only and secure flags that apply to cookies, you do not have that option with tokens. And this means that you still need that functionality and protection, but you have to do it on your own in JavaScript. One advantage that you still have with the token-based approach is that you don't have to worry about CSRF anymore. And this is one of the reasons why, if you look at the latest OWASP top 10, CSRF has been removed in the latest 2017 version. And that's because of the popularity of single-page application architecture, where the cookie-based authentication is going away and it's more token-based. And one reason why CSRF is not a problem anymore is that unlike a cookie that gets sent with every request automatically by the browser, the token is not sent automatically by the browser. The JavaScript code that's running on the browser has to send the token by attaching it to the header by explicit code. So it's no longer like a single-click attack anymore. There's also other changes that happen when you move from a traditional to a single-page application. And one of the things you take for granted is the cache control header. So typically, you would use a cache control header in a traditional web application to prevent caching of sensitive pages. But in the new world, cache control headers are not really relevant anymore because even if you say cache control none, the JavaScript on the page could still store sensitive data into a local storage or a session storage. So this means that you have to look at other things and not just the headers that are coming with every request to determine whether you are storing things securely. So we'll go into a small demo. The intent of this demo is to show why storing data in the different JavaScript storage is different. Like, for example, we have local storage and session storage available, and how storing something in local storage could be a security concern for you. So in this demo, we have, I'll be introducing like 2 web applications that we created. They both have the same functionality. Let me just drag this demo over. So what we have here is a web application where it is a message board application where you can log in and write messages and reply to messages from other people on the board. So what I just showed now is you log into your application, and in the first instance of this message board application, we would be storing the tokens that you get from logging in into the session storage. So to view this, you can go to the developer tools, and there in the session storage, you can see that the tokens are being present. So yeah, like it's blocked out, but the tokens were there in the session storage. But now if the user then decides to close the browser without logging out, let's see what happens. So we have written a simple script that looks into the session storage file that is used by Chrome. So if you just run this code, you see that it does not return anything. Like once you close the browser, the session storage gets cleared automatically, and there's no tokens available on the disk. So now let's go to the second application, which is very similar to the first one, where you log in again. And yeah, so once you're logged in, we can now see that if you go to the developer tools, in this application, they do not use a session storage, but rather use a local storage. So here you can see that the blocked out code is actually the token that's being stored in the browser. So let's see what happens when the user now closes the browser without logging out. So he logs out, but now we run the same script on the local file, which is used for storing the local storage data, and you can see that it still contains a token. The browser does not clear that automatically. So when you're designing your software, make sure that you use session storage instead of local storage for any sensitive data. So that's the key takeaway that we have. Now, the next point is something that's going to be hard for security experts to accept, but this is something that we have to consider because of the design of the single-page applications. So a typical SPA application would have a front-end and a back-end API that interacts with the front-end by giving it new data that's refreshed on the client side. And typically, what we see is that the front-end needs to talk to multiple back-end APIs, and these different back-end APIs would be in different domains. What this means is that now you have the same origin policy in JavaScript that prevent you from accessing these different domains to make requests and get the data back. And the support for that is a cross-origin resource sharing. And typically, you have to use CORS with a single-page application. And the easiest option for CORS is to allow wildcard, like allow all origins to access your resource. And this gets flagged in all security audits as being insecure, but most of the time, it is not really insecure. That's the thing that we wanted to show here. So I'll go into a demo for this again. So why this is okay is because in modern application, we assume that you're not using cookies anymore. If you still have to depend on cookies, then an access control of wildcard star is not a good design. But if it is a token-based application where you send the token in the header, then it should be fine. So let me just show a quick demo for that as well. So what we have here is, again, the same application. So in this application, we scan it with burp, and then we see that there is a cross-origin resource sharing. It's notified as a warning from burp, and it shows that, okay, you have access control allow origin set to star, and that's the reason that the tool burp flags that as an issue. And burp is also good where it gives you an advisory and the reasoning why it flagged that as an issue. So you can see that it is a valid concern as far as burp is concerned, but burp does not fully understand the architecture of the application. It only looks at the requests and the responses that come back, and it tags potential issues. It's up to us to actually validate that it is a valid security issue or not. So how we validate is that you can go to the burp like request history, and you can see that what kind of authentication is being used for this request. So if you actually look at the request that is being sent, you see that it is not a cookie-based request. It has an authorization header, and the authorization header has a bearer token associated with it. So it is probably fine. So you have to validate each of these warnings from burp and actually go deeper into the actual request that is being made to make sure that it's a concern or not. So this is where you, as security professionals, would have to dig deeper and actually find the false positives from the real issues. So that's the end of the demo. So all of this makes the single-page application sound like a great security design because you don't have to worry about CSRF, you don't have to worry about CORS. The framework automatically protects you. However, there are some issues with it as well. So I'll invite Rafael again to talk about the issues.
So as Murali mentioned, we have the elephant in the room, or sad elephant, right? Single-page applications, again, they depend heavily on JavaScript, right? So remember from the architecture, what we have is basically the UI making JavaScript requests to the backend, and you're getting JSON back, updating the UI. So all of this is pure JavaScript. And the problem with that is that cross-site scripting becomes the holy grail for an attacker. If you have a cross-site scripting in a single-page application that uses token-based authentication, that's literally game over. Fortunately, we have some good allies on our side, right? We have frameworks like Angular and React that are safe by default, right? However, we need to make be very careful on some specifics, right? Like Angular or React or any other JavaScript around, they rely on dynamic templates. It's like pretty much you're injecting third-party code on your application. So be careful. When you're using dynamic templates or using third-party libraries, making sure that you trust that you have gone through a security assessment or something that you make sure is safe for you. Also, DOM APIs like inner HTML, they are source for cross-site scripting. Make sure that you're using that in a safe way. And review your application. So Angular, for example. Angular has some ways for you to bypass cross-site scripting protections like bypass trust HTML, bypass trust URL. This might be needed for your application in case you want to load an external resource. However, make sure that when you're using that, you, again, trust the resource that you're loading. That's the tricky part here, right? If you're disabling those security controls by default, make sure that you trust what you're loading on. We have created a demo for that as well to show kind of the big impact that a cross-site scripting can have on a single-page application. So we're going back to the same application that we have created before, and we intentionally added a cross-site scripting vulnerability into that one. Oops. And that's why we don't have live demos. So again, same message board application, okay? And we added on purpose, a cross-site scripting on this page. Is it running? No, it's not running. Hang on. There we go. So if you go to the security tab, which it has a cross-site script vulnerability, we're going to show you kind of basics of cross-site scripting. So our initial payload, it's a simple payload just to show that we have a cross-site scripting here. You have our glorified alert box, but we're not looking for alert box. We're looking for a real way to steal user credentials here. So we crafted a new payload, and we have a website where we control. And using this payload, we're going to inject this JavaScript, read from section storage. And at this point, it doesn't matter if you're using section storage, if you're using local storage. The difference between local storage and section storage is just about persistency. It's not about encryption. It's not about safety at all. It's just about close the browser, section is gone with section storage. So again, we're reading from the section storage token with the cross-site scripting. So we're going to inject our payload into the page, going to the website that we control, voila, that's the token. So again, cross-site scripting is the holy grail. A cross-site scripting in a single-page application that uses token-based authentication is game over. So be careful. We still have some good things to protect us, even if we have a cross-site scripting in our code. CSP, Content Security Policy, is a defense in depth. Security people like us, we love defense in depth. CSP is a good friend, and we should always be pushing for that. Script source self is a great example of a policy, right, that you would allow your page to only load JavaScript from your own source. However, it's just a mitigation, right? You still have a ways to inject cross-site scripting using HTML markup attacks on this one. And also, a caveat on this one is you have like policies like unsafe inline and unsafe eval that might be required for some libraries to execute on that. So this make CSP complex to implement, but I say don't be afraid of CSP. Go and implement CSP. And one good example of a very nice way to implement, or very nice implementation of CSP, is the GitHub case. There's two great blog posts from GitHub from 2016 and 2017. One where they describe the way that they implemented CSP and the post-evaluation after 1 year that have been running the CSP policy. CSP might be tricky, might be heavy, but it's a good ally. It's a good friend of us. So taking back to Murali.
So what are the key takeaways from this talk? So what we are suggesting here is if you're designing single-page applications, you should say goodbye to cookies and use a token-based authentication approach. The other thing which is important is use session storage for all your sensitive data. Do not use local storage or IndexedDB or any of the persistent storage that's available to JavaScript. The other maybe controversial part of the talk is an access control of allowing all origins, the wildcard star is okay, as long as you do not use cookies in your application. And it may also be necessary for your design because you are talking to different backend APIs. They're all on different domains. So you need CORS policies to allow that. And use the framework support for preventing excesses, like Angular and React has a lot of default protections to prevent excesses. Just use that. And if you need to bypass any of the default protections, just review that code very carefully to make sure that you know what you're doing and you have thought about all the implications over there. And the last step is use CSP whenever possible as a defense in depth. It is tricky to implement and it takes a long time to actually get it working in a real world application with all the scenarios that you need to support. But invest in CSP. And these are the key things that we want to say.
And with that, we say thank you, and we have time for some questions.
Yeah.
Awesome. Questions? Questions? Want to go on CSP?
Yeah. So with what we say here is this CSP policy of script source self. What it means is that you cannot do inline JavaScript, which is what XSS tries to do. It tries to inject JavaScript into the page and execute it inline. And that would be prevented by this CSP policy. And this is a very strict policy. And to get it implemented, you probably have to work with the libraries that you use because they are probably using inline eval. So that's the challenge that you have with that.
And scripts itself explicitly says, only load JavaScript from my own domain, my own source.
So I noticed when you said the cores, the star, you always said probably.
Yeah. So, yeah, so.
I was just wondering if you could expand a little bit on that.
Yes.
Qualification.
Yeah, so most single-page applications use a token-based authentication implementation. But there are certain single-page applications that still use cookies for authentication. In those cases, having a CORS policy of wildcard star is not okay. If you have to use cookies, it is not okay to have wildcard.
But so if I am using token,
Yes.
Token only.
token only, I've got no cookies,
Then it is okay, yes. It is not a problem.
It's not a problem for a case like cross-site request forgery.
Yeah. Yes. Yeah. No, it's not like that. So, the question was whether CORS is meant to protect the resource server and not the client side. But the way CORS is implemented, it is an implementation on the browser side. So browser implements this CORS policy where it sees that are you making a simple request or a complex request? If it is a simple request, it just sends that across without a pre-flight. If it is a complex request, it makes a pre-flight request to get the CORS policy and then make the actual request. So it is a client-side implementation. It is not to protect the actual resource. The resource is just saying how the browser should behave.
If the browser is allowed to read that resource or to access that particular resource, it's not on the server side we're protecting, it's the client side. Again, client side protection.
Yeah. Yeah, go ahead. So are you asking about the secure flag in cookies? So the secure flag in cookies, all it does is make sure that the cookie is sent over HTTPS. There is another one called same site, Yeah. So there is, like that's the whole elephant in the room thing. Like in cookies, you have something called as HTTP only flag, which prevents like an XSS from accessing your cookie value. However, with tokens, you don't have that, and you still need to protect your token, and the only way is to prevent XSS now. And this is what the future is. Like, we are all going to single-page applications. We're not in the traditional world anymore. And yeah, you have to worry about XSS. It's a big threat now.
I mean,
Yes. Yeah. Again, this is going back to how browsers behave. With cookies, what the browser sees is that when I make a request to domain A and I have a cookie for domain A, it sends that automatically. So if it's an image request or if it's like a form post, these cookies get sent automatically by the browser. There is no code or JavaScript that sends a cookie, that makes the cookie being sent there. So this is why CSRF is a big problem, because without a CSRF token, another page could make the post request to your domain, and the cookies would get sent automatically. In case of tokens, the browser does not send the token automatically. You need some JavaScript code to run from your domain specifically to send a token to the resource. So since the browser is out of the picture, it is more secure, and you don't really have to worry about like a CSRF token in this case.
yes, because you're sending authorization on the header, then you have to explicitly add that. The JavaScript will have to explicitly add that to the header in order to send the the authorization request or authentication request.
If there's any cookie, like if it's so what the new cookie flag, this cookie flag called same site, which kind of prevents CSRF attacks again. So that's another option if you have to use cookies. But the support for same site is not universal. Not all browsers support that, but most modern browsers will support that. Yeah.
Any other question? All right, thank you, guys. Oh, sorry, go ahead.
Yes.
It's a still defensive depth. No, go ahead.
Yeah, so with CSP, the most strict policy is the CSP script source self, where you do not allow inline JavaScript, you do not allow JavaScript from another domain. So this is the most strictest policy. But still, there are 2 papers on how to steal data using DOM-based like HTML injection. One is called HTML dangling markup. The other one is using a form injected onto the page and using some tricks to like social engineer the user to interact with that HTML. So there are ways around, around CSP, but it's really hard, but there are still ways around.
And that's why you mentioned that's a defense in depth, right? Your first defense is kind of make sure that you're not using dynamic or secure dynamic templates, or your source code is free of cross-site scripting. CSP is another layer, but can be bypassed as well, as Murali explained.
Yeah, read the blog from GitHub about the CSP journey, and that explains the threats and how they defended against it.
It's a really good post. I mean, for everybody that's looking forward to implement CSP or have questions about CSP, these 2 blog posts from GitHub, if you Google GitHub or Bing, GitHub, CSP, GitHub CSP journey, you'll find it's on the top 2 results. It's a really good post and a very good reference for anyone that's interested on that. All right, again, thank you very much for coming. Thanks for staying this afternoon. Appreciate that.